Hello guys, welcome to today's video. In today's video, we are going to talk about absolute value functions using transformations. Okay, so just a quick recap of what we did last time. Last time we have discussed the parent function, right? Parent function. We discussed the graph, okay? How to draw the graph of parent function, right? So the graph of parent function, it has a vertex at origin, okay? And this side, it represents plus x, this side, it represents negative x, okay? And when these two lines, okay, meet each other at origin, making a vertex here, then this is going to be the graph of parent function. Okay, that's what we did. Okay, then we spoke about if generally we represent it with plus minus a x. Okay, so here I'm just taking the positive case. Okay, so if you are going to increase the value of a, what would happen? The graph will get more compressed. This is going to be y equal to 2 times parent function x, right? If I want to sketch the graph for y 3 times parent function x, then it's going to get more compressed, okay? Then it would be this one. But all these three graphs are going to have vertex at origin 0, 0. Okay, then let's take the negative case. Yesterday, we spoke about it. We said that y equals negative of parent function x. So the graph for this is going to be the reflection of this, right? Reflection of this graph around your x-axis. So it's going to be like this. This is going to be y equal to negative parent function x. Okay, so same things here. If you are going to draw it for y equals negative 2 times parent function x, then your graph will get more compressed. Okay, for y, this is y equals negative 2 times parent function x, right? Then if you want to do it for negative 3 times parent function, then it will get more compressed. Okay, and opposite is the case. If you have this graph and you analyze this, so this is going to be more stretched, so and this is going to be more stretched than this. Okay, so the opposite way is the other way is correct too. Okay, so we did this thing yesterday. It was just a quick recap. Okay, now today we are going to start with transformations. Okay, transformations. Now see here, now I'm writing something here. I'm writing here absolute value function with vertex at 0, 0 is defined as y equals fx equals x, right? If you look at this graph, y equals, this is same, y equals modulus function x. If you look at this graph, you can see that this graph has vertex at 0, 0, at 0, 0. Okay, but not all the times the vertex is going to be at 0, 0. There are going to be the cases when your vertex is not going to be at 0, 0, or instead it has some x-intercept on the right or on the left. It has some x-intercept on the right or on the left, or it has some y-intercept, okay, up or down. So if that's the case, then how you are going to sketch the graph, okay, how you are going to sketch the graph, okay. So to overcome this problem, we use absolute value function using transformations, because that's why we said it's a parent function, okay, because this is defined at vertex 0, 0, okay, 0, 0. So this is the parent, okay, because this is the foundation, okay. So if we have x coordinates, positive or negative, or if we have y coordinate, okay, then how your absolute value function is going to behave. So that's why this concept of transformation came, okay, transformation, okay, and it is defined as it is defined it is defined as y equals fx. It's a function, right? It's a function of x, okay. So it's defined as a x minus h plus k, okay, x minus h plus k, okay, where h denotes your x-intercept. You can call it x-intercept, you can call it abscissa, the meaning is the same, and your k represent y-intercept. You can call it y-intercept, you can call it ordinate, okay. So it denotes y-intercept, okay. Here it can be positive, it can be negative. Now see here, positive means, okay, I can mention here positive, open upward, okay. If positive, it will open upward like V, right? And if it is negative, it will open downward, okay. Now we will treat it case by case, okay, case by case, because I don't want to put in everything, and I'm sure then you will get confused, okay. So I just want that we do it step by step, okay, so you have more clarity, okay. So we will just go with x-intercept first. For the time being, I will just put 0 for y-intercept, okay. Now we will do it case by case, okay. So let's do case 1 first, okay. Case 1, okay. Case 1, I'm not deriving anything, okay. I'm just trying to break this whole thing into multiple steps, so that in the final stage, when we assemble everything, you do not have problem to understand the things, okay. So case 1, only, sorry, oh, only x intercept, okay, y intercept 0, So we are going to take the questions where we are going to deal with only x-intercept. Okay, so let's see. For example, I have to sketch graph for x plus 3. Okay, now see here, this is my question. X plus 3. Okay, x plus 3. So if I compare this thing with the standard equation, which was y equals a x minus h plus k, I can see that my h is 3 and y-intercept is 0. Okay, and h is positive 3. H is negative 3. Why? Because x plus 3, it can be written as, see here, it can be written as x minus of negative 3, because my standard definition is in the form of x minus h. Okay, so here, if you compare this with this, so you can see your h is equal to minus 3 and k is equal to 0. Okay, now let's draw the graph. Okay, now you can see here I have x-intercept and I have y-intercept 0, right? So it means now my vertex, okay, so whatever, when I will sketch the graph of this, then this is for sure that my vertex is not going to be at 0, 0. Now we are shifting the vertex to where? To we are going to shift we are shifting the vertex to minus 3, 0. Right? So where is going to be minus 3, 0? Okay, so here positive 1, positive 2, positive 3, 4, 5. Here negative 1, negative 2, negative 3, negative 4, negative 5. Okay, now where can I locate this coordinate on xy plane? Okay, here I have 1, 2, 3, 4, 5. Here minus 1, minus 2, minus 3, minus 4, minus 5. Now minus 3, this is minus 3, 0. Okay, it means my vertex is going to be at this point. Understand? Now if I have to, now see here, minus 3. Okay, minus 3. So for the time being, I'm going to erase this. Okay, and here I will put in the various value of x. Now see here, my x coordinate is my x intercept is minus 3. So I will see, and here mod x means y. Okay, or I can say y. Otherwise, you will get confused. Not mod x, it's modulus of x plus 3. Okay, so for minus 3, the y is 0. Fine. Minus 3, the y is 0. Now, let's take these values for minus 2. Okay, now the expression, the function was, it is y equal x plus 3. Okay, so if I put x minus 2, so minus 2 plus 3, which is going to be modulus 1, 1. So here minus 2, 1. Okay, so minus 2, 1. This is going to be the point. Now, if I put here minus 1, so it will be minus 1 plus 3, which is modulus 2, which is 2, 2, minus 1, 2, 2. Now, see here, because if you look at the a means slope, if you remember, okay, it's 1, so that's why when I'm going 1 unit to the right, so you can see I'm also moving 1 unit up. Yesterday I spoke about this thing. When slope is 1, it means the rate of change of y with respect to x is going to be the same. Okay. And then when I do it for 0, now see here, if I put x0, then y is going to be 3. So 0, 3. Okay. Now let's take some values to the left of minus 3. Okay. So this one is for, now see here, this one. Okay. This part, this part is for y equal x plus 3. I will tell you why I'm writing this here. Okay. And if you take some values, for example minus 4 to the, because my vortex is going to be here at this point, so I'm taking some values that lies right of this. Now I have taken these values because they lie to the right of this, and I am going to take some values that lies to the left of this. Okay. So if I take minus 4, so see here, uh, minus 4 plus 3, which is modulus function of negative 1, which is going to be 1, minus 4, 1. Okay. Then minus 5, so it's going to be minus 5 plus 3 minus 2, 2, 2. So these points are going to be reflection of these points, that's for sure. Okay. So this is going to be the, this is going to be the graph. Okay. Now this graph has vertex at minus 3. Okay. Now come to the point. Why did I say this is y equals x plus 3, this is y equals negative x plus 3, and this whole graph is for y equals combination of both, y equals modulus function of x plus 3. Okay, now come to this point. Why I'm writing this one here. Okay, now see here, y equals x plus 3. Okay, now can I say it is going to be x plus, okay, here it's going to be x plus 3 if x is greater than equal to minus 3, and it's going to be minus of x plus 3 if x is less than minus 3. The same thing that we did yesterday. Modulus function x is equal to x if x is greater than equal to 0, and modulus function x equal negative x if x is less than 0. So I did the same thing. Okay, so this side you can see greater than equal to negative 3 x plus 3. That's what I write here. And x less than minus 3 as you move towards left, so you will get y equal negative of x plus 3. I hope this question is clear. Okay. I can erase this because I need more space. So we'll take few more questions. We'll take few more questions. All right. So first one we did was y equals x plus 3. Okay, now let's go to number 2. Number 2, x minus 2. Okay, now here I'm going to write the equation y equal a x minus h plus k. Okay, and here I'm writing h x intercept and k y intercept. Now we are just discussing case 1 means only x intercept, which means y intercept 0. Okay, because we broke this whole thing into few cases. Okay, and we are discussing it step by step. Okay, now I have to do it for my question is y equals modulus function of x minus 2. Okay, now I'm given with x intercept. It means the vertex is not going to be at the origin because I'm given with x intercept. Okay, if you compare this equation with this equation, you can see on comparing, can I write on comparing with 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 uh, with equation of transformation h is 2 and y is 0. Okay, so let's do the graph. This side +1, +2, +3, +4, +5. This side -1, -2, -3, -4, -5, so on up to -infinity. This side +1, 2, 3, 4, 5, 6, positive. This side -4, 5, -6. Okay, now see here. Now my y-intercept is 0 and my x-intercept is 2. So if I have to write it in the form of ordered pair, right? So it's going to be 2, 0. Okay, in terms of ordered pair, right? It's going to be 2, 0. So it means that vertex is going to be 2, 0. Vertex is going to be 2, 0. So where is 2, 0? This is 2, 0. Right? So the vertex is going to be formed here. Okay, so what I will do now, I'm going to write it here, y equal modulus function of -2. Okay, and here I will just put in the values, here x, here y. Okay, if I put, now see here, I will take some values that lies to the right of 2 and some values that lies to the left of 2. Okay, so let's start with the right. If I put x, okay, 3, 4, 5, and here this side 1, 2, 1, 0. Okay, now if I put 3 here, it's going to be 3 minus 2. Modulus function of 1 is 1. If I put 4 here, 4 minus 2, modulus function of 2 is 2. If I put 5 here, 5 minus 2, 3, modulus function 3. If I put 2 here, 0. 2, it's already, okay. 1 for 1, it's going to be 1 minus 2. Modulus function of negative 1, that's going to be positive 1. If I put x0, then minus 2, and the modulus function of negative 2 is positive 2. Then here, minus 1, minus 2, negative 3. Modulus function of negative 3, positive 3. Okay, so let's 3. Now see here, you can analyze the things. Okay, now see here, I've told you here, because a is 1, a is just like a slope, right? So if slope is 1, you can see when you are moving one step towards the left or right, then you can look at how y is changing. It is also changing one step or 1 unit. Okay, so 3 4 5, yes, so 3 1 3 1, this is going to be the point. 4 2, this is going to be the point. 5 3, this is going to be the point. So this one. Okay, and if you go to other side, for 1 1, for 1 1, for 0 2 2, and for negative 1 3, negative 1 3, negative 1 3, here this one. So if I'm going to join this, it's going to be like this, okay. Now see here, modulus function of x minus 2, so it's going to be x minus 2 if x is greater than equal to 2, and minus of x minus 2 if x is less than 2. Now greater than 2 means this is y equals x minus 2, and this one, okay, this one y equals negative x minus 2. Okay, so I hope this is clear. Okay, we can take one more question for better clarity. Okay, so let's take this one, y equals x minus x plus 6, fine, x plus 6. Okay, so I'm going to erase it. Okay, we can do one thing. We can now go with graphs that opens downward. So here it's going to be y equals negative of x plus 6, negative of x plus 6, negative of absolute value function of x plus 6. We have to do it. Okay, now if you compare this with this equation, so what can you see? You can see I write it like this, minus x minus 6, so that it looks similar to this. Okay, so here you can see your h is minus 6 and your k is 0, right? Let's draw the graph. This is the graph, xy plane, 2 4 6 8 10 12 14, all positive values. This side, negative 2, negative 4, negative 6, negative 8, negative 10, negative 12, negative 14. Okay, here 2 4 6 8 10 12 14, all positives. And here negative 2, negative 4, negative 6, negative 8, negative 10, negative 12, negative 14, so on. Okay, now we have to go for this thing. Okay, now if I'm given with x-intercept, I'm given with y-intercept, so from here I can make the ordered pair of number minus x 0, which is going to be my vertex. Okay, so here your vertex is going to be at minus x 0, means this point. Okay, now what I will do, I will just write this one, y equals negative x plus 6. We'll put in the values of x and y and see where it will take us, right? X, y. So I will take some values towards the right and some values towards the left. Okay, let's put minus 4, minus 4. Okay, if I put minus 4, minus 4 plus 6, 2. But outside, negative, so negative 2. Okay, negative 4, so I get negative 2. Okay, I can also go for negative 5. So for negative 5, I think negative 5, it's going to be at negative 1, right? Then for negative 2, for negative 2, negative 2 plus 6, positive 4, minus 4, negative 2, negative 4, this one. Okay, then 0, then check for 0. It's going to be negative 6. For 0, negative 6. Oh, here. Okay, so this is going to be something like this. Okay, something like this. Okay, and now check for some values here. Minus 8, minus 8. Now see here, minus 8 plus 6, minus 2, right? For 0, it's minus 6. Minus 8 plus 6, minus 2. And the modulus function of minus 2 is 2, but negative sign is here, so minus 2. Minus 8, minus 2. I've told you it's going to be the reflection of this. Okay, minus 8, minus 2 here. Then minus 10, minus 10 plus 6. It's going to be 4, minus 4, minus 4. See, minus 4. So it's going to be here. Okay, minus 4, minus 4, minus 8, minus 2, minus 10 here. And okay, so if you draw it, it's going to be this. Okay, now see here, as you can see, okay, as you can see that because here we have negative, here we have negative, and you know that if you have negative, okay, if you have negative here, then your if you have negative with a, then what's going to happen? Your graph will open downwards. That's why it's opening downward. Now see here, this is this is this is x y equals negative x plus 6, right? So this thing is going to be x plus 6 if x is greater than minus 6, right? Greater than equal to minus 6, and negative of x plus 6 if x is less than negative 6. This minus just signifies that it will open downward, right? So for x greater than equal to minus 6 means this side greater than, right? So this is going to be y equal x plus 6, and this is going to be y equal negative of x plus 6. And this whole graph represents y absolute function of x plus 6. I hope you understand it, right? All right, so you can do one thing. This is going to be your homework, okay? Number 4, you can do it for y equal negative of x minus 4, okay? This is going to be your homework, okay? Homework. Okay, so our case one is finished. Okay, now let's switch to case 2. Okay, let's switch to case 2. Let's switch to case 2. We are going to use the same transformation definition. Okay, nothing is going to change. We are just going to change change not change, but we are just going to suppose that this time we are going to suppose that x-intercept is 0 and we have y-intercept. Okay, see here, let's do it with question. Okay, case 2. Now case 2, only y-intercept. Y-intercept, your x-intercept is 0. Okay, let's do the question. Y equal x plus 2. Okay, now my question is y equal absolute function of x plus 2. This is my equation. Okay, so what happened now? On comparing with the standard definition, okay, what we have h 0 and k 2, right? We have h0 and k2. So if I have to arrange them in an ordered pair of number, my coordinate would be 0, 2, right? 0, 2. So it means this is going to be the point where vertex will be formed, right? So let's see. We'll design the graph for this. Here 2, 4, 6, 8, 10. Here negative 2, negative 4, negative 6, negative 8, negative 10. And here 2, 4, 6, 8, 10, positive, 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 positive. Here minus 2, minus 4, minus 6, minus 8, minus 10. All right. So the vertex is going to be formed at 0, 2. So where is 0, 2? So x-intercept is 0 and y-axis, okay? So this is going to be the point. Okay, this is going to be the point. Right? Now, let's do it. Y equal plus 2. Let's make the table xy right. So here you can put any values. For example, for 0 it is 2. For 2 2 plus 2 4. Okay, for 4 plus 2 6, right? For 6 plus 2 8. You can do this. Okay, 8 plus 2 10. You can do the same for negative values, right? So here for 0, okay, 2, minus 2, minus 2, 2 plus 2, 4, minus 4. See here, the modulus of minus 4 is positive 4, positive 4 plus 2, 6, minus 6, it's going to be 8. Okay, now draw all the coordinates. Okay, 2 for 2, 4, this point, then 4, 6, this point, then 6, 8, this point, then 8, 10, this point. Okay, so if you join, it's going to be this. Okay, same on the other side. See here, minus 2, minus 2, 4, minus 4, minus 6, minus 6, this is minus 6, minus 8, and minus 8, minus 10. So if you join these two, so you can see the vortex is made at 0, 2. Okay, and now, okay, y equal modulus function x plus 2. Now can I say it's going to be x plus 2? Okay, it's going to be x plus 2 for x greater than equal to 0, and x plus 2 and minus x plus 2 for, it's going to be, no, it was okay, it's going to be negative of x plus 2 or minus x plus 2 if x is less than 0. Okay, so for this one, x plus 2, and for this one, 2 minus x, and this whole graph is for y equal absolute function x plus 2. I hope this is clear. Okay, now take one more example. I can erase it. Okay, just erase the lines. Oh, all right. Okay, I will take, this time I will take y equal negative absolute function x plus 2. Okay, this one, 2 minus 4 minus 6 minus 8 minus 10 minus 12. Okay, and here we have minus 2, sorry, plus 2. Okay, so I have to do it for this is this we are discussing case 2. Sorry, I erased it. Means only y intercept x intercept 0. Okay, we are discussing this case. Okay, so my question is y equal to negative absolute function x plus 2. Okay, now if I compare this equation with this one, here I can see that I have h 0 and k. This time k I will take negative 2. Okay, negative 2. Why? Because you will have more clarity, because we are going to discuss the separate case where my y-intercept is below x-axis. Okay, in that case it will expand your horizon. Okay, so this is minus 2, then k is minus 2. Okay, so if I if I arrange them in ordered pair, so it's going to be 0, minus 2, right? So this is going to be your vertex. Okay, so vertex 0, minus 2. This is going to be the vertex. Now, what I will do here, I will just write this one and just check the values of x and y. What values will I get for y if I put x something? Okay. Now, let's start with, for 0, it's already minus 2. For 2, now see here, for 2, if it is 2, then it will become minus 2, minus 2, minus 4. Okay. If minus 4, if minus 4, minus 4, positive 4, then again negative, minus 6. Sorry, plus 4, plus 4, minus 6. Then plus 6, plus 6, then minus 8, right? Then plus 8, plus 8, then minus 10. Okay, let's do it for negative. Minus 2, minus 2, again minus 4. Minus 4, again the value, plus 4, but with this minus, minus 4, minus 6. And then here same, minus 6, minus 8, and one more we can take, minus 8, minus 10. Okay, now let's see. So if I took my positive 2, minus 4, 4, minus 6, 6, minus 8, 6, minus 8 here, 8, minus 10 here. So this is going to be the line. Okay, this is going to be the line. And on this side, see here, minus 2, minus 4, again the reflection of all these points. Okay, so minus 6 here, then minus 6, minus 8, minus 8, minus 8, minus 10 here. Okay, so it's going to be something like this. Okay, now let's do some observation. Now, okay, now y equals this, right? Now, can I say it's going to be minus x minus 2, right? Minus x minus 2 if x is greater than equal to 0, right? And it's going to be x minus 2 if x is less than 0. See here, it's going to be positive x or negative x. So positive x, then it become negative x minus 2 if negative x, negative of negative, positive x minus 2. Okay, so I hope this is clear. Okay, so if you see greater than x greater than equal to 0, so this is minus x minus 2 or minus x plus 2, and this side it is x minus 2, and this whole represents y equal negative of absolute function x minus 2. Okay, so I hope case 1, case 2, when you have only x-intercept and then you have only y-intercept, these two cases are clear to you, and we solve these cases using transformation. Okay, so next time when I will do another video, we are going to discuss case 3 when we have x-intercept and we have y-intercept as well. Then how the graph is going to behave, or how we are going to sketch the graph. Okay, so I hope you understand the things. Okay, if you don't, please, the point where you do not understand, please pause the video, try to think. Okay, think from multiple angles. Okay, and I hope that's going to resolve and make things easier for you. Okay, so that's it for today. I will see you next time. Thank you very much and have a great time. Bye bye.